All right. So, hi everyone. Welcome to our month's webinar. We're always looking forward to the end of the month because we have this amazing webinars from amazing people who give us amazing content. So, our speaker today is the one and only Nuku. I won't even try pronouncing his second name because my tongue might slip. So he's going to tell us his name in full when he starts to speak. So Nuku is a software developer or a software engineer, say. He loves to work and solve problems. He will tell us a lot more about himself once he begins to speak. He is a full stack developer and very passionate about problem solving. He has worked with Alan and in projects in the banking industry and the music industry. Sounds amazing. So for the next 60 minutes, he's going to wow us with Elixir and the outside world. I'm not sure what that topic is about because when once you read that topic, it doesn't quite give you specific thing like I'm going to talk about live view, I'm going to talk about channels. So it gives you some anticipation on what he's going to talk about. So I'm really excited about this one and I hope you guys are too. So just a little bit of housekeeping. This is a live session, so we might experience some technical difficulties. When that happens, we'll try to recover as fast as we possibly can. So keep your mics muted if you're not speaking. You can keep your videos on or off, depending on your preferences. And now we can begin. Nuku, without further ado, I'd like to welcome you. The floor is yours.
Okay, thanks. Um, Thanks for the nice introduction.
All right, I've stopped sharing my screen. I think you're free to share yours.
Okay, can you see my screen now?
Sure, clear.
Okay, all right. Hi everybody, I'm Nuku. Um, I like to program just like I think everybody else on this program or chat. So um, I like Erlang and Elixir a lot due to one or two experiences that I had and some observations that I got as I was going through the software well. So yeah, today mainly we are come to talk about how Elixir and to a certain extent all the Beam languages, some of the Beam languages talk to the outside world. So how the Beam communicates with programs which are outside of itself. So um, that's a little bit of the mystery that Getty was talking about. So that's a little icing for the rest of it. Okay, so let's start with the Erlang and the Elixir and the Elixir ecosystem itself. There are a couple of things which Elixir and its ecosystem of languages are good at. So they are good at concurrency, scalability, reliability, and depending on your taste, expressiveness. So those who may be from the Python and Ruby world would like Elixir. Those who are from the Prologue world would probably like Erlang. Those from the Lisp world would like less flavored Erlang, you know. So I mean, there's some food also for the static type people. That's caramel and all that. So there's something for everybody, but they all have one thing in common, and that they are good at concurrency, scalability, reliability, and expressiveness, depending on the language you are comfortable with. That I was saying, but um, Erlang is not good at everything. You know, in programming, you have to use the right tool for the right job. So Erlang is not good at everything. So there are some cases whereby you may need to do some stuff which Elixir or Erlang or it's what is not good at. Okay, so for instance, you may have cases where you may need to use mature external libraries, like maybe for audio and video processing. There's a tool called FFmpeg, which is very old and very mature. It's written in, I think, C or C++, one of them, and is the state of the art when it comes to streaming and that kind of stuff. And yeah, it's good at that, but it's it's not good at concurrency and all that because of the language that's written in, because there's a lot of sharing in C and C++. There isn't isolation of data in memory. Lipsodium is a cryptographic library, which is also a bit old. It's used for a lot of cryptography stuff. So it's also state of the art, but there are no such libraries in Erlang and Elixir. So sometimes to do some very, very secure stuff, you may need to use either of these two things. In some cases, you may need to work on some hardware time systems like embedded system, and you may also speed. Like as I said earlier with FFmpeg and Lipsodium, they all need speed, and Erlang is not so good at number crunching at a certain extent, as I said. I think they talked about Nifs last time. I think Getty.
Sorry, I missed the last webinar.
Oh, okay, no problem.
Okay.
Okay, there was some talk about Nifs. So hard real-time systems, Erlang is not so good at working on that directly. So you may need to interface with it. Sometimes the company or the project they are working on, we have some old code or some vendor code which is not in Erlang or Elixir. So in that case also you need to interface. And then I mean some people like their languages. I mean, some people are in love with their own languages. So and sometimes also the developers at a company may not have familiarity with the Erlang or the Elixir code, Elixir environment. So you may need to work with them to interface with that old code base before you develop your new stuff. Yeah. So yeah, those are some of the reasons. But this is Joe Armstrong, the creator of the Erlang programming language. And he said something very interesting. He said, when you're programming, there are three good rules that you can follow. Make it work, make it beautiful, and then make it fast. Make it um, make it work means that the primary purpose of what you're writing is for a customer or yourself. So your first work is to make sure that the program works. All the parts works, all the APIs and so on and so forth, before you think about making it extremely readable for other people. The reason I make it work first is that you have to thinking about shipping your code off to the customers, whether it's a website, web application, a CLI, an embedded system. The primary reason is that somebody has to use it before you or the company, or if you are just making it for fun, somebody has to use it before you see the results. So the ideal case is that you bring it to the customer. It mustn't be super beautiful, it mustn't be super fast, but you have to make the companies use it. As you begin to iterate, you can make it beatable and then fast as a last result if you need it, because fast code is error prone. Yeah, so it can get like that. So okay. So for those bracefulls who want to go outside the being, you have four spears. Oh, sorry, I left one out. Ports, Nifs, distributed airline, and then sorry, there's one here like web services, REST services, and so on and so forth. Okay. Okay. A port is a byte-oriented interface to an external program. The external program can run in another OS process or be dynamically linked, like DLLs or SO files. But it runs as part of the Elixir or Erlang runtime. The second case where it's a DLL, it's called a linked-in driver. Okay. So in the first case, it's just called a port. In the second case, it's called a port driver or a linked-in driver. Port drivers, which are the second case, they are the most efficient way of talking to the Beam VM. So the Beam, Elixir, and all the other Erlang language ecosystem. But the problem with the port drivers is that they can, if it crashes, you lose all your concurrency and resiliency and all those guarantees that other parts of the program depend on and your end users depend on. So faulty port drivers can be a big problem. So It's advised that you use question as a last resort. But not being said, if you have programmed it very well and you've tested it very well, you can still use it. There are some built-in applications which use ports in the beam itself, like when you're using network sockets, TCP, UDP, when you're monitoring the state of the operating system, using the OS mon applications and so on and so forth, among other things. Okay, this is a diagram of how ports and the ports on the left side, and then the linking drivers or the port drivers are on the right side. So you can see how they interact with the OS, the external application, and then the LAN runtime system. So you have a connected process which links the which you link to the port, and then a port.
Sorry, Nuku. Yeah, I can't. I think I can see the slides, but there's something you've mentioned about ports on the left,
yeah,
and links to the right, but I can't seem to see it.
Oh,
Personally, I can only see the slides talking to the outside one. So I don't know if we are on the same screen.
Yeah, the current slide that we can see is talking to the outside world. That's the slide you can see.
Yes.
So maybe if you try to share your screen again, it might be okay.
Okay, so I should share my screen again.
Yes, please.
Okay, all right. Can you see my screen?
Just a moment, it's still sharing. Yes, can you move to the next slide, please? No, it's not moving. So it seems you're sharing the screen, the presenter view maybe, because you can just see ports.
Oh.
Yeah, it's not moving.
See. Okay. Can you see the screen now? Can you see?
Yeah, we can. We can see the cursor.
Okay. Can you see this slide also?
Yes, you can see this slide. This is exactly, this is what we're seeing. Nope.
Okay.
Just come back to that again, to the list of slides. That is exactly what you're seeing. Yep.
Okay, so you're okay now?
No, yeah. So now what you're seeing is what we are seeing.
All right, okay.
Wait, how do you know that what he's seeing is what we are seeing?
Once the icons are active, now I know he's on the same page. Right now they're all inactive. So he's somewhere else. That is my assumption.
Okay.
So I think Nuku, since doing the presentation is problematic, you can click through the slides.
Okay, all right.
Just do the sharing again.
Okay, all right. Can you see the screen now?
Yes, so we can just click on, right now if you start, awesome. That's now perfect.
Okay.
Yes, we missed a little bit of the slide, so you can go through them quickly. Yeah.
Okay, all right. A port is a bind-oriented interface to the external program. The external program can be an executable program, or maybe a shell script or whatever. It can run in another OS process, or you can link it to the LAN runtime system, in which case it's called a port driver. Port drivers are very fast, but they also, when they crash, it can mess up your whole application, not just itself. So it will leak into the LAN system they are developing. So the advice is that you program it and test it very well, and then use it as a last result. Okay. That being said, there are some port applications in the LAN system itself. I think they've tested and done all that. So when you're opening sockets, when you're talking to the OS and so on and so forth, use ports and ports drivers. So this is two images showing a port and then a port, a normal port on the left side, and then a port driver on the right side. So you can see that on the right side, the port driver lives in the Erlang emulator, but on the left side, it doesn't live in the Erlang emulator. You understand? So the port library becomes a shared library. So on the right side, the external program is part of the shared library, In the left side, it's completely separate from the Erlang runtime system. So errors with the port driver, errors with the external program won't affect your runtime system. Yeah. We'll come back to the demo. Okay. A Nif is also another option. A Nif is a function that is written in C, Rust. There's another programming language called Zig, or other languages which we may not be aware of. Okay, Nifs appear as normal functions to the caller. They're also very efficient. They are good for short calculations which don't have side effects. Yeah, and they should run in less than 1 second, at least. But they also have the same problem that they're also not safe, because a crash in a Nif brings the emulator down also. So as with port drivers, you have to be careful how you use them. There are some built-in functions like the length, function Erlang.length, as well as some other applications like crypto, the tracing application, the Zebly application, all make use of Nifs. For Nifs that take more than 1 second, you have 3 options. You can call the you can designate the Nif as a yielding Nif, a threaded Nif, or a dirty Nif. Okay. With the yielding Nif, what happens with the yielding Nif is that you create the Nif and then you create a callback which will tell the Nif to continue later after the 1 second is up and execute the code later. It's a bit complicated, but according to the Erlang documentation, it's the best is the best way to develop Nifs. Yeah, but it can get complicated. Yeah, very quickly. With threaded Nifs, you create a new thread, a new OS thread to handle the Nif. But that also has a problem of context switches, because when the operating system is creating a context switch, it isn't like the Erlang runtime system. It can be slow, use a lot of memory, and so on and so forth, depending on the load on the system and all that. So sometimes your time guarantees won't be, your latency guarantees won't be met. Then you have dirty Nifs. Dirty Nifs fall into memory bound and CPU bound. So you can create a Nif that is memory bound or CPU bound. But these ones are also depending on the number of cores on your operating system. So anyway, so it's up to you, the one you want to use, and how well you can test it and make sure that it's working well. Okay, let me give a small example of a Nif. Okay, so this is a very this is a simple C program. This is a simple C program, and that's I wanted to use. So you have a full and a bar function, and the full adds 1 to the input. The bar multiplies it by 2. Okay, so you create this is how, sorry, this is the Nif, and so this is the initial function. This is the Nif. So Elixir, to some extent, Erlang, they have some header files that you have to use when you are creating Nifs. So there's a format in which you have to write them. So you have to, the first 2 values are the return types for the complex calculations that you are doing. The Nif and ascoterm is the return type of the full function, but it's a data type of in the Nif header file. So it picks that return data type from there. It's defined there. So if you really want to really understand and get into it, you can go into that file. So for each function that you have to that you want to call, you have to write a function for it. So the first one and the second one is that the full is for the full, the bar is for the bar. And then there's an extra variable here too, where you have to make some definitions. Here too, you have to make a definition so that the Elixir code can know the particular Nif is called. This is all C code, but you can write it in. There are other ways you can write it in Python and other programming languages. This is the Nif code in Elixir. So you have the full function, you have the bar function, and then you have the code which calls the Nifs. Okay, so let me run a quick example so that we can. Please, if you have any questions, you can ask. Okay, so first of all, you have to compile the Nif that you want to use. This is a simple example, but you can actually add these commands to the mix file. So every time you run the mix compile function, it would compile the file and do all the necessary stuff for you. So in this case, it's generated a file Nif Elixir. So you've generated anyway, Nif Elixir.so file. That's the executable file. After that, you compile this one. I think I compiled it already. That's why it's giving this warning about upgrades. But and I'm not going to see it will. Okay, let me remove this file and do it again. Okay, so it's done. It is compiled it. So okay, so you added one. Added one, two. Oh, sorry. So multiply this one also by 2. Yeah, so that is a small example of using Nifs. Okay, let's go ahead. Okay, you also have distributed Elixir. Distributed Elixir comes to play when you have 2 or more Elixir nodes communicating with each other and executing commands on the other nodes. The program on the other node may be a C node, Rust node, normal Erlang node, which is running a port, etc. All the nodes use the same Erlang semantics for connecting to nodes, sending messages, error handling, remote execution, although the encoding and decoding or the method protocol may be different, and the program on the other side may be different. So in this case, what all that is trying to say that you can have 2 different Erlang nodes, and then you can connect them using the nets adm.ping, and then you can just call the remote node to do what's supposed to. You can call the functions to the remote node. But before you call the function, you have to register the process as a global process. Then you can call the functions on the remote node transparently, just like we are calling a function on the Erlang node. Okay. the thing is that practically speaking, sometimes people use the raw nifs and pots like I just used earlier. They use them one by one, but most of the time people use libraries and wrappers to wrap all the functionalities of the nifs and pots. So the wrappers and the libraries make it do a lot of the boilerplate for you. So for instance, the code like this, the wrapper can create this code for you. To some extent, it can create this code for you, but it depends on the wrapper too. So they make working with Nifs very easy, some of them. So Elixir is very popular in Erlang. I've used it myself in one or two projects, and it was quite good. Porcelain is popular in the Elixir world. Unifex is also very popular. It's Unifex is used by the memory framework, which is an audio visual framework which uses audio video streaming. It uses FFmpeg a lot, but they've created a very nice tool which can enable to create the stubs for the C functions, so that you don't have to be bothering yourself writing all of the machining code or the code to take data to from Elixir to C. Rustler is writing Rust sniffs in Rustler is writing Rust sniffs. Rust sniffs are, from what I heard, they are safer than C. So because of various features of the Rust programming languages, they have some really advanced memory handling stuff, and then some a type system called the ownership system. So it's very interesting. Yeah. Ziegler is the new kid on the block. It's a new programming language, but it seems to, from what I've read, it seems to solve quite a lot of the problems with the nifs I was talking about earlier, with things like yielding nif and then threaded nifs and so on and so forth. So, and it's very good at interfacing with C. So it seems to hold a lot of promise. So you can investigate that also. Yeah, it's not long, but at the end of the day, before you write speed code, you have to do your own benchmarks. Don't depend on what anybody has to say. Do your own benchmarks and see whether you need the speed in your program. If you do need it, write as much as possible in Elixir or the other bean languages, and then the small bits which are left, you code it in C, Rust, Zig, or any other language that you want, and then try using ports. If those don't work, you can go to Nifs, and then you can go to C notes and so on and so forth in that order. Yeah. Sometimes also some people are I read in the with the membrane framework that they used a lot of C instead of Rust, because they were saying that with Rust they had to do a lot of wrappers around the FMPG C code. So they had to write a lot of stuff in there which they were not too comfortable with, some panic syntax and all that. So they were saying that they would prefer to use C. So yeah, that's them. So that was their choice. That was their situation. So they did that, but it's your choice, you know. Yeah, you have a lot of options, you know. Erlang is not an island. Elixir is not an island. So you have a lot of options that you can use. The source code is in this repository, and then these are some of the links to some interesting stuff about dirty schedulers and then zigs and then nifs. Okay, so if you have any questions, please feel free.
Awesome. Very good. Great session, Nuku. It was quite short but sweet. Thank you for your presentation. So we will take questions now. I don't see any there's one question on Lido. Maybe I could just post it to you. So Nif is just a function written in one of the mentioned languages. That's the question.
Please, can you repeat it?
Is a Nif just any of the functions mentioned in the, sorry, let me just read it as it is. Is a Nif just any function written in one of those mentioned languages? I believe you mentioned C and Rust and the new one, Enter.
Zig.
Zig. Yeah. So is a Nif just any function written in those languages?
It's okay. I would say it's a function written in those languages, but it's written in a specific way, and it's supposed to interface with the Elixir and the beam in a particular way. So it's just a normal function. Yeah, it's a normal function that has an input and an output. Yeah, so it's not any complicated thing. It may be the language you are using it in, which may or may not be safe, which may make it difficult. Yeah, to interface with the beam system.
Awesome. Great. I think that's answered that question. So any other questions from the audience? Feel free to just unmute and ask at this point.
Not really a question, but a request. Maybe you could share with us the links to these notes, or maybe you could just share with us the slides so that you can go through the links.
Okay, sure. That'll be fine. I'll do that.
Awesome. Thank you, Frank. Any other questions or comments from the audience on Nuku's presentation? So Nuku, where can we find you after this? Or is that within the link? Can see it.
Oh, okay. Let me, you can find me on Twitter. Let me write my chat there.
Okay.
At Nimbo on Twitter. Yeah. And then.
Great. All right. You can catch Nuku on Twitter. I'm pretty sure he responds to your DM. And since there is no more questions, I hope I'm not locking out anyone. I'd like to give a really, really big thank you to you, Nuku, for the session. Okay, there's an intro here. Are you in a position to unmute, Ronald? Oh, but he's just asking, apologies for joining late. Is there a way where the recording, the meeting can be accessed? Yes, this can be accessed in, we can send the link to the drive in our WhatsApp group. Hopefully you're in that group. If not, I could add you. So maybe just, you could send me an email.
Yeah, and just to add.
Yeah. Go on.
Just to add. So I think the video is going to be prepared and also be uploaded to YouTube, right?
Yes, sure. Oh, I think he's asking where to get that link. So, could you drop your email and then we could probably get it to you if you're not in the WhatsApp group. I could also add you in the group if you're willing. I hope that works for you. All right, Nuku, thank you so much for your presentation. This was fun. We learned a lot from this, and we're hoping to have you in more of our events. Thank you, guys. Feel free to drop off, and thank you so much for coming. Yes.
Okay. Cool stuff. See you on the chat.
Ronald, you could kindly send me your email. I'll be happy to add you to it. Cool. Thanks, guys. Bye.